Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. So please share and subscribe our YouTube channel and you learn the physics and mathematical methods of physics. All these days we are under the mathematical sub methods of physics. After finishing of the mathematical of the methods of physics, we have to follow the CSIR syllabus topic by topic, maybe classical mechanics and electromagnetic theory, quantum mechanics, statistical and thermodynamics and electronics and experimental methods, atomic and molecular physics and condensed matter physics and nuclear and particle physics. All the topics, one question I will deliver in the YouTube. That is our main motto. So some people will get the benefit how we have to solve the problems in a CSR examination. Right? Clear? Now we will see. Today we want to discuss about the Fourier. Yesterday's class we discussed about the Fourier series. Fourier series, their Parseval's theorem I took from the Parseval's theorem. One question, previous question from the CSIR I drag and I told to you. So today we are discussing about the Fourier transform. Fourier transform question, when they asked once, you have to see CSIR June 2016. CSIR June 2016. What is the Fourier transform of integral dx e power ikx f of x of f of x is equal to Kronecker delta of x summation n is equal to infinite is equal n is equal to 1 to infinite d to the power of n by dx to the power of n Kronecker delta of x, where Kronecker delta is the Dirac delta function, right? This is the CSIR question in June 2006. CSIR people asked this question. First, you have to see what is a Fourier transform. The Fourier transform of the f of x is the function. Once you have to see the Fourier transform of gi of omega is equal to 1 by root 2 phi gi of omega is equal to, which one we have to write? 1 by root 2 phi integral minus infinite to plus infinite, integral minus infinite to plus infinite, integral which one we have to write here? Integral minus infinite to plus infinite, minus infinite to plus infinite gi integration of so omega is equal to 1 by root 2 phi integral minus infinite to plus infinite. So the derivative of that function, what we have to write? The derivative of the function, first derivative you have to take dou f by dou t e to the power of so you have to take the function, what is that? E to the power of ikx, e to the power of ikx into f of x, we have to dou f by dou t e to the power of ikx, that function is equal to 1 by root 2 phi integral minus infinite to plus infinite dou f by dou t e to the power of plus ikx into dt. If you have to take this function, then what we have to write? The Fourier transform of derivative of that function is equal to, the Fourier transform of derivative that function is equal to, which one we have to write? Minus ik all to the power of, if you have to take nth derivative, minus ik all to the power of n into Fourier transform of, which one we have to write? The Fourier transform of f of t we have to write. Fourier transform of f of t, which one we have to take? The Fourier transform of f of t you have to write. Clear? Suppose if you have to take here this one, you have to consider as a f of t, you have to consider minus infinite to plus infinite, you have to take it as a f of x or f of t, you have to take here f of t you have to consider, because it is dt is there, f of t you have to consider. Clear? Once again you have to see the Fourier integral form of the Fourier transform of gi of omega or gi of k you have to write. Instead of I, instead of k you have to take gi of k is equal to 1 by root 2 phi integral minus infinite to plus infinite f of t e to the power of ikx into dt. This is the Fourier transform formula. So from this Fourier transform formula, I have to write one principle. What is that principle? Once you have to see the Fourier transform of nth derivative of that function is equal to minus ik all to the power of minus ik. Here minus you have to take, it will come plus. Here plus you have to take, it will come the minus. Minus ik all to the power of n, Fourier transform of f of t. First we have to take the function f of x. Function is the f of x is there. So that is the function. Once you have to see f of x is equal to, what is that function? F of x is equal to Dirac delta function of f of x plus summation n is equal to 1 to infinite. Summation n is equal to 1 to infinite. D to the power of n is divided by dx to the power of n into Kronecker delta of x. This one I am rearranging. Once you have to see f of x is equal to summation n is equal to 0 to infinite. Summation n is equal to 0 to infinite d to the power of n by dx to the power of n Kronecker delta of x I am writing. So again I have to rearrange this one. Summation n is equal to 0 to infinite Kronecker delta derivative of nth derivative of x is it will come. This is the f of x value. Which value we are getting? This value. This value is f of x value we have to get. This is the f of x value we are getting. F of x is equal to how much we are getting? Once you have to see f of x is equal to summation n is equal to 0 to infinite d to the power of n is divided by dx to the power of n into Kronecker delta of x is equal to, which one we have to write here? Summation n is equal to 0 to infinite Kronecker delta to the power of n of x I am writing. Kronecker delta to the power of n of x I am writing. Clear? Once you know the f of x, then what we have to calculate? The Fourier transform of integral dx e to the power of ikx f of x they want to ask. How we have to calculate? Once you have to see the Fourier transform of we want to learn first Dirac delta function. The Fourier transform of Dirac delta function is equal to 1. The Fourier transform of nth derivative of f of x is equal to nth derivative of f of x is equal to, which one we have to write? Minus ik all to the power of n into Fourier transform of Dirac delta of x. Fourier transform of Dirac delta of x. So therefore what we have to write? Minus ik all to the power of n into Fourier transform of Dirac delta function x is equal to 1. That is equal to, it will come minus ik all to the power of n it will come. Which one it is? Fourier transform of Dirac delta of x is equal to. The Fourier transform of Dirac delta of x is equal to, we got this value. Now what is our ultimate goal? Our ultimate goal is the Fourier transform of f of x we need. Already we derived the f of x is equal to, what is that? Fourier transform of summation n is equal to 0 to infinite Dirac delta to the power of x into dx. This is the Fourier transform. Clear? Now you have to see what we have to write. Therefore, summation n is equal to 0 to infinite minus ik all to the power of n we are writing. Now you have to expand these terms. Minus ik is equal to ik all to the power of 0 is equal to 1 minus ik. So plus ik whole square minus ik whole cube minus ik whole cube plus ik whole to the power of 4 minus and so on it will come. Clear? Now you have to expand this. How we have to expand? 1 minus ik whole to the power of minus 1 we have to write. 1 minus ik whole to the power of minus 1. By using the binomial expansion we have to write this one. So therefore you have to take 1 by So which one we have to write? 1 plus ik whole to the power of minus 1 we have to write. So therefore 1 by 1 plus ik it will come. This is the correct answer concerning to that problem, right? This is very, very important to calculate that one. What is your answer? Your answer is 1 by 1 plus ik is your answer. What is our option? Option B is correct. Which option is correct? Option B. 1 by 1 plus ik is correct. How simple it is. Just you know the formula, how you have to simplify this question. Easily you able to get the answer. That is the thing. Once you have to see. This is the Fourier transform in terms of k I have to write. So 1 by root 2 phi integral minus infinite to plus infinite f of t e to the power of ikx dx. Therefore, Fourier transform of derivative of that function is equal to, this is the formula. Our function is f of x is equal to Kronecker Dirac delta x plus summation n is equal to 1 to infinite d to the power of n is divided by dx to the power of n Dirac delta of x, where Dirac delta of x is the Kronecker delta x is a Dirac delta x. Like this we have to calculate. It is very simple. You able to get in your competitive examination. Clear? Right. So if you like my teaching, please go for our app, that is the Quantum Online Academy app is there. If you have Android mobile phone, you have to download our app and see our courses in play that store, app store. You have to see courses will appear. In that courses you have to choose that CSIR and GATE physics course live plus recorded classes is available, and JL physics and DL physics content course also available, and CSIR and GATE mathematical methods of physics. CSIR and GATE mathematical methods of physics, it is a purely recorded one only. It is purely recorded, not live. So purely recorded. So these recorded courses are available on our app. Within the couple of days it should be completed. We are in the end of the topics of this mathematical methods of physics. If you really like, if you really want to learn the subject, you have to take our app and you learn the subject. Thank you so much. Please share and subscribe our channel, and daily you have to watch our CSIR old questions how we have to solve in the examination. Thank you so much.